In this video, we'll look at two examples of solving a separable differential equation. So the first example asks us to solve dy dx equals x minus 5 all over y squared. And we start out by multiplying both sides by dx. So that cancels out the dx here, and what we're left with is dy equals x minus 5 over y squared, and then dx. And our next step now is to get rid of the y on the left. So we do that by multiplying both sides of the equation by dy. Or sorry, both sides of the equation by y. So I'm going to multiply by y squared. I'm going to multiply by y squared. That cancels out the y there. And then what I now have is y squared dy equals x minus 5 dx. Next step is we're going to integrate on both sides. So we're going to integrate y squared, we're going to integrate x minus 5. And so an antiderivative of y squared is 1 over 3 y cubed. And then an antiderivative of x minus 5 is 1/2 x squared minus 5x. And both of these have a constant of integration, but I'm just going to combine that right here. This right here is an implicit solution. And I can solve this for y by multiplying both sides times 3. So if we multiply both sides times 3, right, then we have multiply that by 3, and then we have that times 3. And then we get 3 over 2x squared minus 15x. And then 3 times c, I can just call that, that's a constant, I'll call that k. And then 3 times 1/3 y cubed, that's just y cubed. And then finally, we can take the cube root on both sides. So we take the cube root on that side, we take the cube root on that side, and then our final explicit solution is y cubed equals our final solution is y equals the cube root of 3 over 2 x squared minus 15x plus k. need to figure out what the value of that constant is if this problem would have an initial condition, but it does not. So this is our final answer. And if you're bored on a Saturday evening, you can take this function, plug it into this differential equation to see if it is indeed a solution. Okay, here's the next example. We have to solve dy dx equals y minus 1 over x plus 3 with an initial condition y of negative 1 equals 0. So the first thing to note here is that we do have a separable equation because we can write y minus 1 over x plus 3 as 1 over x plus 3 times y minus 1 over 1. So we have p of x times, or sorry, g of x times p of y as our function. So let's take a look at this differential equation, right? We have dy dx equals y minus 1 over x plus 3. Our first step here is to multiply both sides times dx. And so the dx's cancel out, and then we're left with dy equals, and I'm going to write this out as a product, so I have y minus 1 over 1 times 1 over x plus 3 dx. So I want to get rid of the y on the side where I have my dx, so I'm then going to multiply both sides by 1 over y minus 1. So this whole thing will cancel with that, and my equation now becomes, I'll put it here on the left, one over y minus 1 dy equals 1 over x plus 3 dx. And then I will integrate both sides. And I get the integral of one over y minus 1 dy equals the integral of 1 over x plus 3 dx. Now both of these integrals require a natural logarithm. So what we have on the left, when you integrate that, we get ln of y minus 1. And then on the right, I get ln of x plus 3, and then there's a common constant of integration that's c here. So this is basically an explicit solution, or sorry, this is an implicit solution to the differential equation, but we still need to figure out what that value of c is, and that will come from the initial condition here. Now, there are two approaches to finding that c. So the first approach is we're going to solve for y first and then find c. So we're first going to solve this for y and then use this to find c. Or the second solution is we're going to solve for c first, get that out of the way, and then we're going to find y. So I would suggest that you try the first method yourself and see if you can get the same answer, but I will follow the second approach here. So we're going to find c first. Now note that the initial condition y equals -1 equals 0, right? That means that y equals 0 when x equals -1. So we're going to take our solution that we have so far, the implicit solution, and we're going to plug in those values for y and x. I'm going to take, for my y, I'm going to take 0, and then for my x, I am going to get -1. And so we get ln of 1. Oops. So we get, on the left, we get ln of 1 equals ln of 2 plus c. And ln of 1, that's equal to 0. And so we can solve for c by subtracting ln of 2 on both sides. So we have negative ln of 2 equals c. That's our value of c. So what we're going to do is we're going to plug that into our solution here, and then we're going to solve for y. So now we're going to solve for y. And so we have ln of the absolute value of y minus 1 equals ln of the absolute value of x plus 3, and then minus ln of 2. So in order to solve or to get rid of this natural log that's in front of the y minus 1, we're going to exponentiate with respect to e on both sides. So I'm going to take e, and then I'm going to copy down what I have on the left. So e to the power ln of y minus 1 equals, and then I have e to the power ln of x plus 3 minus ln of 2. And the e and the ln, they cancel each other out. So on the left-hand side, I have the absolute value of y minus 1 equals. And on the right-hand side, I'm going to combine these two natural logs into a single logarithm. And when you subtract two logarithms, you can divide their arguments. So this then becomes e to the power ln of x plus 3 absolute value over 2. And now the e and the ln cancel out. So let me show you what the rule for logarithms is that I use there. So I have ln of a minus ln of b, that equals ln of a over b. So that's what I have here. The e and the ln cancel each other out. So now my equation is y minus 1 absolute value equals x plus 3 absolute value over 2. So now, how do I get rid of the absolute value symbols here? Well, now I know that y minus 1 has to equal plus or minus x plus 3 in absolute value times 1/2, right? I'll just put that divided by 2 as a factor 1/2 in front. So now, which of these two solutions is the true solution, the positive or the negative? We're going to have to check our initial condition. We're going to have to check the initial condition that was y of negative 1 equals 0. So what we have here is that when you try 0 minus 1, right? 0 minus 1 equals positive 1/2 times the absolute value of negative 1 plus 3. Right, so we have negative 1 plus 3. We get 2 times 1/2 is 1, and then we have negative 1. So that one doesn't work out, right? That is wrong. And then if we try the other solution, so the negative solution, we get 0 minus 1 equals negative 1/2 times -1 plus 3. And then we get -1 equals -1. That one checks out. So at this point, what we have is y minus 1, sorry, y minus 1 equals -1/2 absolute value of x plus 3. And we have to worry a little bit about, do we have what branch of this absolute value we have. So think about x plus 3. So note that x plus 3 is equal to x plus 3 if x plus 3 is greater than 0, and it's negative x plus 3 if x plus 3 is less than 0. So if we rewrite that, we have that x plus 3 in absolute value is equal to x plus 3 if x is greater than -3, and it's negative x minus 3 if x is less than -3. So all I did here is rewrite this, subtract 3, I get x is greater than -3. And now let's think about our initial condition. So if we look at our initial condition, x is -1. So the initial condition tells us that x equals -1 and y equals 0. But if x is -1, that's greater than -3. So this right-hand side just becomes x plus 3. So we can simplify that a bit more, and we get that y minus 1 equals -1/2 times x plus 3. And now simplify this down all the way, we get y minus 1 equals -1/2 x minus 3 over 2. And adding 1 to both sides of the equation, we now get that y equals -1/2 x minus 1/2. And that is our final answer.